So welcome students to the new lecture on analysis. So in the previous lecture we have started one theorem and we will finish up this theorem within 5 minutes. Theorem states that if there is P star partition, okay, if there is P star partition and P star has one more point then P, means P star is the refinement of P, okay. P star is the refinement of P, okay. So we have to prove that LP star F, okay, that is greater than equal to LPF, okay. So what we have done, there is a P star, okay, that is your A equal to x naught comma x1 comma x2 so on xi minus 1 comma z comma xi, okay, xi plus 1 so on xn equal to b. This was our P star and this is one additional point, okay, additional point. So what we have done here, okay, what we have done here, we have already considering that m1 dash is greater than mi and m1 double dash greater than equal to m1 double dash is greater than equal to mi, okay, this is glp, okay. So now we are considering here LP star F, okay. From here we are starting now LP star F. So what is LP star F? That is summation I equal to 1 to n mi delta I, okay. Now see, this one is your P star. So divide this into some parts here. So up to this part, okay. So you can write down summation I equal to 1 to I minus 1, okay, mi delta I plus for this interval xi minus 1 and z we are considering m1 dash. So this is the length here z minus xi minus 1, okay. For this interval we are considering here m1 double dash, okay, xi minus z, okay, plus I equal to I plus 1 up to n mi delta I, okay. So this is our P star and we are finding out the LP star F. Up to this point we are considering mi delta I. For this one, this interval we are considering m1 dash. This is the length z minus xi minus 1, you can say width, plus m1 double dash, okay. As m1 dash is greater than mi, so you will write down greater than equal to I equal to I minus 1 mi delta I plus I equal to 1 to n, sorry, not mi z minus xi minus 1, okay, plus since m1 double dash is greater than equal to mi, so you will write down mi xi minus z, okay, plus summation I equal to I plus 1 n mi delta I. Okay, so this can be written as summation I equal to 1 to n mi delta I. So that is written as LP star F, that is greater than equal to LPF. So in this way you can show this is your answer. Okay, so this is the part of the theorem. Similarly we can prove here UP star F is less than equal to UPF. Okay, so this is the part of the theorem. Okay, so in this way we'll always says LP star F, P star is the refinement of P, so its lower Riemann integral is always greater than your LPF, your original partition. So let's start the important, very important part, that is your Riemann integration. Okay, Riemann integration. Should I raise it now? Yes. Should I raise it now? Yes. Should I raise it now? Okay. Now let's concentrate on the very important part, that is Riemann integrability. Very important. So Riemann integrability. How will you will find Riemann integrable? Okay, Riemann integrability. Okay, now see what is Riemann integrable. Let f be the bounded function. Let f be the bounded function in the interval a comma b. Okay, as we know m b minus a less than equal to LPF. This we have already proved. Less than equal to UPF, less than equal to M B minus A. This we have already proved. Okay, fine. Okay, therefore we can say the two sets LPF, okay, for P belongs to A comma B, okay, and UPF P belongs to A comma B, okay, are both of these sets are both bounded below, okay, bounded below, and okay, are both bounded below. Okay, so you can say by MB minus A. Similarly, you can say it is bounded above also. Okay. So least upper bound, least upper bound, okay, least upper bound of LPF bounded below and bounded above by MB minus A. Okay. So least, we can say we can find the least upper bound of LPF. What is the least upper bound of LPF? That is MB minus A, least upper bound. P belongs to A comma B. Okay. And GLB of UPF P belongs to A comma B exist. Okay, fine. So LUB, least upper bound of LPF P belongs to A comma B is known as is known as lower Riemann integral. Okay, this is known as lower Riemann integral, least upper bound of LPF, or and it is written as and it is written as lower Riemann integral. This will be written as integration A, okay, integration A lower Riemann integral in this way. B f of x dx. This is lower Riemann integrals. This is the definition for your lower Riemann integral. LUB of LPF. Okay. So once again I repeat, this theorem we have already done. So from here we can say LPF is both bounded below and bounded above. So LUB, least upper bound of LPF, is known as your lower Riemann integral. Okay. Should I erase it now? Should I erase it now?
Yes, sir.
Okay. Similarly, all these are theoretical part. Okay, we will do one question, then you can easily understand. Okay. So you can say lower Riemann integral f of x dx, that is always LUB, okay, of LPF for P belongs to A comma B. Similarly, upper Riemann integral that is A B bar f of x dx, that is your GLB. So it will be written as GLB, greatest lower bound of your, yes, greatest lower bound of UPF. Okay, P belongs to A comma B. So we will find these two type of integrals, lower in Riemann integral and upper Riemann integral. Okay, a function,
सर
yes,
सर वो
yes,
लोअर
Raman?
राइमन इंटीग्रल में ए के नीचे जो बार है वो नीचे रहता है सर।
हाँ हाँ वो नीचे रहेगा. That is only for the representation.
ओके
Okay,
सर।
so a function f of x is called R integral, means Riemann integral, or you can say Riemann integral if if lower Riemann integral, okay, that is equal to your upper Riemann integral, and we will find all these type of integrals. Okay, we will do one question, then you can understand easily. Okay, should I read it now?
नो सर वेट अ मिनट।
Okay, okay.
एक्सक्यूज मी सर।
Yes, beta.
सर डैश क्यों लगाई है आपने ए के नीचे
Where?
और बी पर?
Where?
ए,
Where?
ए के नीचे और बी के ऊपर
Yes,
डैश
yes,
लगाई
yes,
है।
yes. This is only for the representation, that it represent lower Riemann integral, okay, and it represent your upper Riemann integral, nothing else. Okay, it is only the representation. Okay, it is nothing with the it is bar or something else. It is only for the representation. Okay,
यस सर।
okay, fine. So let's start the question. Should I read it now?
यस सर।
Okay. Now let's start the question. Everyone must concentrate because I am doing the first question. Question is, if f of x equal to 2x plus 3, okay, show that f belongs to Rx, okay, on 0 comma 2, and integration of this one is 0 to 2 f of x dx is 10. Okay, what does it mean? We have to show it is Riemann integrable. It means that it is Riemann integrable. So it is the sign of this one, Rx. Okay, now first start step 1. Okay, step 1 is, what is step 1? Since x belongs to 0 comma 2, okay, it means that 0 less than x less than 2, okay, multiply by 2, it is 2x, 4, then add by 3, okay, so it means that function is bounded, okay, means you will show it is bounded function, okay, so f of x is bounded function. First of all, we have to show it is bounded function. This is step number 1. Okay, This is the first step to show it is bounded function. Okay. Now, second step. The interval 0, 2 divides into n equal subintervals. N equal subintervals. Yes or no? Okay. Fine. So how will you divide it into n equal subinterval? What is h? H is 2 minus 0 upon n. So it is your h, that is 2 by n. Yes. Fine. So in the first step we have to show it is bounded. Very simple thing, just 0 less than x less than 2. Just find it is bounded function. Okay. Step number 2 is every time you have to convert this into n equal subintervals. Okay. Should I erase it now? Yes.
Yes, sir.
What about other students? Only 2 or 3 students are studying here. Amanpreet, Harkomal and Rohit. What about other students? So many students are sitting in the class. Yes, you must respond. Okay. Now see. Yes, Rohit, what will be the partition? Just tell me the partitions.
So first will be 2 by n minus 0.
0. First one is 0.
No, sir.
Then 2
First
by
one is
n.
0. Yes, sir. 2 by
Yes,
n.
okay. Next will be
2 by n plus 1.
4
No.
by 1. 4 by n.
4 by n.
Yes, okay.
6
Then
by n.
continuing this way, continuing this way, continuing this way. What will be last one?
2n by n.
2n by n means 2n by n means 2. Yes or no?
Yes, sir.
Yes, it is 2. Okay. In between, I can take here 2in and 2i minus 1n. Okay. Fine. Any doubt?
सर आपने
Okay.
2n/2 लिखा है सर.
Yes, 2n by 2 equal to 2n by n, sorry. Okay, fine. Now compare it with very interesting thing. Compare it with P, that is 0 equal to x naught, x1, x2, so on, xi minus 1, xi, so on, xn equal to 2. Now I am comparing it with. Yes. What will be xi here? Yes, Rohit. What will be xi?
2i by
Sir,
n.
2 by n.
2i by
2i
n.
by n.
Yes. Good. 2i by n. Okay. Now see. Tell me, it is f is monotonically increasing or decreasing? Yes. 2x plus 3 is increasing or decreasing function?
Sir, increasing, sir.
Huh?
Increasing function.
Increasing. Yes, it is increasing function. Okay. Increasing. Okay. Now see, what is mi? What is mi? Mi is your GLP, greatest lower bound, for the function f of x belongs to xi minus 1 comma xi. Rohit, at which point you will get the GLB? At this point or this point? It is increasing. Yes. At which point you will get it is GLB?
So xi minus 1.
Yes. Rohit, xi minus 1. If it is increasing, if it is decreasing, then this is very important concept. If it is increasing, at which point? Yes, xi. Good. Good. So I
सर
get here f.
इंक्रीजिंग में xi कैसे आया सर ये GLB xi minus 1
Yes. Here,
सर मैं
because
carefully
interval is
observe
your, it is general interval. Monotonically increasing. Increasing means your this value is your smaller one. This value is your larger one. Okay. So increasing means at the lower point, we are finding GLB, lower bound, lower value. And lower value will be always obtained at xi minus 1. Okay. So what is xi? Xi is 2i by n. What is xi minus 1? That is 2i minus 1 upon n. What is function? Function is your 2x plus 3. See this thing. Function is 2x plus 3. So you will get here 2xi minus 1 plus 3. Okay. So it will be twice xi minus 1. So what is xi minus 1? So it is 2i minus 1 upon n plus 3. Any doubt up to this point? Any doubt up to this point?
No, sir.
Okay, fine. So it means that you are getting here 4i minus 1 upon n plus 3. Okay, now tell me what is mi, capital Mi. I am asking the question from Arkomal. What is mi? You will write down definition.
Sir, L
Fx,
will be f of x such that x
f of x,
belongs
yes, yes.
to xi minus xi minus 1.
Okay, at which point you will find here?
So
At
lower
which point?
bound.
Upper.
Yes, sir. Xi.
Xi. Okay, good. So xi. So it will be written as 2xi plus 3. Okay. So it will be written as 2 into 2i upon n plus 3. This type of question will be asked in the exam. So 4i upon n plus 3. Any doubt up to this point? Any doubt you can ask now because it is the first question. Yes, any doubt?
No, sir.
Arkomal, Rohit, Mansha, Megha. If you are sitting in the class, you must uh, study something, understand something. Okay. Should I move to next part?
Yes, sir.
Yes, sir.
Okay, good. Fine. So I'm erasing it now. Now we are calculating LPF. Yes, LPF. What is LPF? LPF is summation I equal to 1 to n mi delta I. Okay, fine. So what is mi? Mi we have already find. So it is I equal to 1 to n mi is 4I minus 1 upon n plus 3. Yes, Rohit, what is delta I, width of the interval?
Sir,
Delta
2
I,
by n.
2 by n. Yes, 2 by n. Now multiply with, okay. So it will be summation I equal to 1 to n. Okay. So it will be 8I minus 1 upon n square plus 6 by n. I equal to 1 to n. Okay, fine. So we have to calculate the value. So see this one, 8 upon n square, I equal to 1 to n. Okay, I minus 1. Okay, 6 by n common, summation I equal to 1 to n. Okay, we will do a question. Okay, we will practice all these questions. 8 by n square. Okay, put I equal to 1, so it is 0. Put I equal to 2, it is 1. Put I equal to 3, it is 2. So on n minus 1. Okay, 6 by n, 1 plus 1 plus 1 plus up to n. Okay, so its sum is n. Okay, 1 plus 1 plus 1 n times. So into n. So now see, if you remember, one important formula, 1 plus 2 plus 3 up to n. Formula was n into n plus 1 by 2. This we have already studied in lower classes, but we are finding it 1 plus 2 plus 3 up to n minus 1. Okay, what we will do? We will do just put the value of n minus 1 here. So it is n minus 1 plus 1 upon 2. So it means that it is your 8 upon n square n into n minus 1 upon 2. This got cancelled out, this got cancelled out. Okay, fine. Okay, so calculate the value. Calculate the value. So it is your 6 plus 4. Okay, take out n square common, n square 1 minus 1 by n upon n square. Okay, this got cancelled out, this got cancelled out, and you will get this value 4 1 minus 1 by n plus 6. This is the value for your LPF. Okay, LPF. Any doubt regarding this, Rohit, Harkomal, Mansha? Okay, any doubt you can ask now. Okay,
No, sir.
yes, Abhishek, Amanpreet, Amisha, Ankit. Okay, clear, very good. So I hope so. Dharvi, Chelsea, इतने अच्छे अच्छे स्टूडेंट्स क्लास में बैठे हैं. तो ओके, should I raise it now? Fine.
Yes,
Yes.
sir.
Okay, and UPF within 1 minute it will complete now. UPF. What is UPF? UPF is your summation I equal to 1 to n mi delta I. Okay. What is mi? Mi we have already find. So it is your 4I upon n plus 3 into 2 by n. So we will easily calculate. It is 8 by n square I plus 6 by n summation I equal to 1 to n, summation I equal to 1 to n. Okay, so take out 8 by n square common, summation I equal to 1 to n, I plus 6 by n, I equal to 1 to n, 1. So it is 6 by n into n. Okay, so it is 8 by n square, 1 plus 2 plus 3 up to n. Okay, so it is your 8 by n square, n into n plus 1 upon 2 plus 6. So it will be your 4, take out n square common, n square 1 plus 1 by n plus 6. So it is equal. Okay, so this is your LPF and UPF. Okay, any doubt regarding this UPF? Yes, Raksha, Rohan, Rohit, Samriti, Shivalika, Surinder Kumar. No? Okay. Just one. Okay. So now we are finishing this question now. We have find LPF and we have find UPF. And last important step, okay, that will relate our Riemann integral. Just see. Okay. Should I read it now? Yes?
Yes, sir.
Fine. So last step, very, very important step. Step number 4, I think so. Step number 4 or step number 3? Okay. Step number 4. See this one. We are finding it Riemann integral, lower Riemann integral f of x dx. Okay. Very, very important step I am writing down. Okay, it is step number 3. Okay, very, very important writing down. I am writing down limit. This is always can be evaluated. Limit norm tends to 0 means norm is very, very small. F of x dx. Yes. Okay. What is p? Sorry, not f of x dx. Sorry. Not f of x dx. It is LPF. LPF. Okay. So always you have to find lower Riemann integral, that is norm tends to 0 LPF. What is norm here? What is P? P is your 2 by n.
2 by n.
Okay. So when P tends to 0, when P tends to 0, n tends to infinity. Yes or no? N tends to infinity. So you will write down limit n tend to infinity LPF. Okay. So what is LPF? LPF we have find out. What is the value of LPF? LPF was 4 1 minus 1 by n plus 6. Okay. Sorry, infinity. Limit n tend to infinity. So when n tend to infinity, something on infinity is what? 0. So you will get here 10 answer. Okay, 10. In this way, you will get the integral. Similarly, upper integral 0 to 2 bar f of x dx is always same thing. Limit norm tends to 0 UPF. Okay. So similarly, limit n tend to infinity. What is UPF? UPF is your 4 1 plus 1 by n plus 6. So it comes out to be 10 here again. So see this one, lower Riemann integral f of x dx is equal to upper Riemann integral. Okay, fine. Hence it is f belongs to R integral. Hence it is Riemann integral. Okay. And what is the answer now? It is 10. In this way, you can find the integral, Riemann integral. Okay. So basically, everything depends how you find LPF and UPF. It is increasing or decreasing. This you have to decide at that time. Okay. If it is increasing, then xi minus 1 stands for your mi, small mi. If it is you're decreasing, then your small mi stands for xi. Okay, so everything depends upon how you calculate UPF and LPF. Okay, so this is the another integration. You have already find the definite integral in the lower classes, but Riemann integration is different thing. We have to calculate LPF and UPF. Okay.
सर एक बार थोड़ा एक्सप्लेन फिर से कर दीजिए ना, वो नॉर्म टेंस टू 0 ही क्यों लिया हमने?
Norm, because n we do not know. Okay, n tends to 0. Means sorry, n not n. We do not know how many sub intervals are there. Okay, let us suppose this one is 0 and 2. Okay, we do not know how many sub intervals are there. Okay, so if we take the norm 10 to 0, width of that interval very small. Okay, width of interval very small. We will do one theorem for this thing also. Okay, if norm tends to 0, then we can find the number of we can find the integral. Let us suppose I have the function this one, f of x. Okay, so in the lower classes, what we have done? We have done here it is your lower value, here it is your upper value, and we are dividing this into n equal sub intervals. Okay, if the width of the sub interval is very small, that condition we are considering here. We will do one theorem for this thing also. Okay,
सर ये
but
n
for
क्या है? नंबर ऑफ सब इंटरवल.
which one?
सर n is number of sub interval क्योंकि n आपने
Yes,
infinity लिया है.
yes. N is number of sub intervals, and there is no condition on the number of sub intervals. Okay, because n tends to infinity, we do not know how many numbers are there. It may be 1000, maybe 1 lakh also. So okay, so 0 and 2, that is very small width for that
Yes
interval.
sir,
Okay,
clear sir, clear. Thank you.
okay. So I hope so. Yeah, you understand this topic, how to find the Riemann integration. We will do more questions in the class also, so that you can understand very well. So thank you very much for attending the lecture. Thank you very much.
सर